Thank you for joining us at the Unlocked conference here and for taking the time to give a presentation around full text search. One of the things that I'm kind of curious about is how does Valkey do query process planning? Can you talk a little bit about that?
Yeah, for sure. I think that maybe looking at from a perspective of the very beginning, we were kind of fortunate that we started the Valkey Search at the time that vector search became an issue in the industry, and while we architected Valkey Search from the very beginning, we were fortunate enough to see the whole picture rather than, to introduce vector search as an add-on to an existing architecture. The process of the design, we have made one of the major goals is to make sure that the performance is going to be top of the line. And the use cases for Valkey Search are low latency and high throughput. While everything is remaining in memory, still utilizing the hardware efficiently involves some challenges around how do you best utilize the CPU cores, avoid contention, and so forth. So we have, as we discussed in the presentation, we have implemented a time slice mechanism where we where it allows us to reduce the contention and have a lock-free algorithm processing of the read pass. And this allows us to scale very efficiently with the amount of CPU core, almost linearly. The time slice mechanism allows us to support concurrent reads and concurrent writes, but not concurrent reads and write at the same time, while the time slice span is very short, so the latency that a user experience is very short, while processing workloads which involve a mix of read and write at the same time. The query processing itself, we have incorporated a planning logic that determine what is the best route to execute the query. The query itself specify a filter and a vector section. And the way that the query is being processed and determine we support two routes. One what we call pre-filtering, where we narrow down the data set and build in memory a small subset of the data set and let the vector search operate on top of it. And we have another flavor which we call inline filtering, where we basically throughout the vector, finding the top matching nodes, we evaluate, before we add a node to the results set, we evaluate it against the query. The inline filtering is very effective when your data set is very large and the filter is not effective. Like for instance, if your query says that your data set is all the restaurant in the world, and you are specifying a filter to narrow down the data set on the US. Huge amount of data. Obviously, we cannot keep this in memory. So the inline filter is very helpful in this case, but pre-filter is very useful when the filter narrow down the data set to a very small amount of records.
So you talked probably more about CPU than memory just now, but for avoiding index searching, obviously is very heavy on memory usage. What kind of trade-offs, or how do you make the decision of how much of the index to store in memory?
Basically, this is controlled by the user. When the user specifies the index itself, everything is stored in memory. So we stay true to Valkey. Everything is remain in memory. And the user may specify multiple indexes, and this sometimes gets handy if it wants to narrow down the search to a particular use cases that are predetermined. It is a very effective technique.
Awesome, excellent. Well, thank you very much again for speaking at the conference. We really appreciate it,
Thank
and
you.
look forward to talking to you more.
Thank you.